To finish, we're going to talk about hydrogen bonds. And the hydrogen bonds are a type of weak bonds. And if you remember, we're talking about covalent bonds, ionic bonds, and finally weak bonds. So this is the end. These weak bonds are important in the chemistry of life. Why? Because most large molecules are held in their three-dimensional functional shape by weak bonds. So a protein, a DNA to be functional, uh, they should have hydrogen bonds that they will give them the three-dimensional structure, and we will talk that in more detail in the future chapters. But this shape of the DNA, this type of escalator that hold together the nucleotides, are weak bonds, yeah, that are hydrogen bonds. So again, let's go to the water molecule. And if you remember, this section will be positive, while the oxygen will be negative, and this will give very interesting properties when not with one molecule, but with hundreds of molecules, thousands of molecules of water. Why? Because you remember that the positive always interact with the negative, and they will two attract to each other. So look what happened. Here you have one molecule of water that it will attract another molecule of water, and this molecule of water will also attract this molecule of water, and this one will attract this one, and this one will attract this one. And it's always in the same way. The hydrogen bond is charged positively, so it will interact with the neighbor molecules, will attack each other, and this is how you form a hydrogen bond. But hydrogen bonds not only have to have oxygen, is not always with water. For example, in the DNA, you can have nitrogen and hydrogen. Yeah, nitrogen will be more positive and hydrogen will be more negative. So in that case, you find another type of weak bond. It will have an attraction. So you will make another hydrogen bond, but without oxygen. So for that reason, every time that you have a positive charged region, is always a hydrogen atom. If for that reason, it's called a hydrogen bond. So it doesn't have to be water. It doesn't have to be oxygen, it could be nitrogen, and you will also form a hydrogen bond, like in the case of the DNA, that two nucleotides come together. And we will talk more in detail in future chapters. So remember that chemical reaction can make and break chemical bonds. So here you have hydrogen and oxygen, and you're going to form water. So you're going to make a chemical reaction to produce water. So here you have your products, and here you have your reactants. And to do that, you have to, as I said, you have to make new bonds between hydrogen and oxygen, and you have also to break all these chemical bonds. And the formation of water from hydrogen and oxygen is an example of a chemical reaction. The reactants, as I said before, are hydrogen and oxygen, and they convert into water, that it will be the product. And remember, chemical reaction do not create or destroy matter. The chemical reaction only rearrange matter. So you still have four molecules here of hydrogen, and here you will have one, two, three, and four hydrogen atoms, and you will have also one and two oxygen, and here you will have one and two oxygens. So you're not creating matter, you're just rearranging those atoms. To finish, I'm going to show you an example of a chemical reaction that is a little bit more complex. That is photosynthesis. That is a chemical reaction that is essential for the life on our planet. And here are the reactants, and here are the products. So plants take carbon dioxide from the air and water using their roots, and as a result, they use sunlight that power the conversion, that allows them to break these chemical bonds and form new chemical bonds. And as a result, the products are glucose and oxygen. However, if you see this chemical reaction going in the opposite direction, you will find respiration. So we don't need light, and this will go in the opposite direction, and we take humans and all animals take oxygen and sugar as reactants, and we produce water and carbon dioxide. And in either direction, photosynthesis or respiration, the chemical reaction don't need to create or destroy matter. The chemical reaction are only rearranging matter. And if you have any question or any doubt, just let me know and we can solve it in class. Have a good day.